Hello class and welcome to, once again, this screencast lesson. And we're going to be talking about simple machines, using simple machines to lift a load. And just be sure to go through the entire video and prepare yourself either mentally or even if you want, take some notes so that when you come to class you'll be able to have a kind of a head start or a leg up on making the mind map associated with the video lesson. So let's start this. Using simple machines to lift a load. I wonder what that means. I must keep working and move these rocks to clear the path. Let's help this guy. I'm glad you came along to help. I've been having trouble moving this boulder out of the way. I'm just about to try one of these shovels. Let's try it with him. Wow, it worked, guys. Any ideas why it might have worked? Might have something to do with the length of the shovel. Seems to be the tallest one. Let's continue to investigate why. Machines such as a shovel make it easier to lift things. I had to move that big rock and it wouldn't budge when I pushed it by hand. When I put the long-handed shovel, which acts as a lever under the rock, I was able to pry it up slightly and move it a short distance. That's because when I moved the end of the handle a long distance, the blade of the shovel moved a shorter distance but with more force. Now, let's look at the definitions of these words. Load. What is load? A load is the force or weight of the object to be moved. What about effort? Effort, the amount of force to be put into move the load. Kind of similar to just the normal word in English, effort. Did you put effort to study for that test? Well, it's the amount of time, energy you would have put into your studies. Kind of similar play on the word. Fulcrum, the point on which a lever rests or is supported and on which it pivots. The force that a simple machine exerts on an object can be measured using a spring scale. The numbers printed on the side of the spring scale show the force of gravity in newtons, capital N, and the mass of kilograms, kg. A 1 kilogram of mass weighs 10 newtons near the surface of the earth. When you use the scale to lift a 1 kilogram mass by hand, you see that the force of gravity is 10 newtons. The force you apply to lift the load is also 10 newtons. Let's see how these items measure up. We have sand, pebbles, and bricks. Well, the sand is 20 newtons. Pebbles, 10 newtons. Bricks, 20 newtons. Let's do some more investigating together. Click next to move to our next activity. I have an idea. Before we begin the investigations with simple machines, I'll move this box of salt by hand using no simple machines. How many newtons do you think it will take to lift the 1 kilogram box of salt 20 centimeters by hand? Type your answer into the box. Well, I'll give you a few seconds to have your own guess, guys, and then I'll put in what I think it could be. Okay, if you're not ready yet, feel free to pause the video, but let me just put in 10 newtons. Great guess. Well, let's see what the actual force is. Okay, can you read the spring scale? How many newtons did it take? Okay, reading the spring scale, it seems to say 10 newtons. Oh, sounds good to me. All right. Simple machines. Well, these simple machines investigated include levers, pulleys, and inclined planes. Simple machines were invented to make our work easier. One of the main advantages of simple machines is that they provide mechanical advantage. Mechanical advantage is the ability of a machine to apply more force to an object when the operator moves a part of the machine a greater distance. Distance is traded for force. Well, let's stop here, guys. Great work.